A material contains one iron 3 plus ion with magnetic moment 5 Bohr magneton and one chromium 3 plus ion with magnetic moment 3 Bohr magneton per unit cell. The iron 3 plus ions are arranged parallel to each other and chromium anti-parallel. So iron 3 plus ions are arranged parallel to each other and anti-parallel to the chromium 3 plus ions. Given that the unit cell volume is 120 angstrom cube, what is the magnetization of the material? Give your answer in SI and CGS. And then we have something to think about here. So we can note that there's going to be a net magnetic moment per unit cell. Net magnetic moment per unit cell. Since there is only one iron 3 plus ion per unit cell, it's going to be plus 5 Bohr magnetons, which is anti-parallel to chromium, so minus 3 Bohr magnetons. So this will be 2 Bohr magnetons. For example, this could be a body-centered cubic structure where we have the iron ions at the corners and chromium ion is at the body center. So that would be one scenario where you would have 1/8 times 8, one iron 3 plus ion per unit cell and one chromium 3 plus ion in the body center. Now, what is this magnetic moment? The magnetic moment, net magnetic moment per unit cell will be equal to 2 Bohr magnetons. Bohr magneton is EH bar divided by 2 mass of the electron charge, reduced Planck constant divided by twice mass of the electron. So these 2's will cancel and we will find that this is 1.6 10 to minus 19 coulombs times 6.63 10 to minus 34 joule seconds, that's Planck's constant, divided by 2 pi. So this is 2 pi times mass of the electron 9.11 rest mass 10 to minus 31 kilograms. So this gives us 9.2 so it's the 2 Bohr magneton, so it gives us 2 times 9.27 10 to minus 24 ampere meter square. So this one, the 10 to minus 24, 9 10 to minus 24, this is the Bohr magneton. So this is 2 Bohr magnetons. And therefore the magnetization we will find in SI units will be 2 Bohr magnetons divided by the volume, which is 120 angstrom cube. So it's 10 to minus 30 meter cube. So this will give us 2 times 9.27 10 to minus 24 ampere meter square, 2 Bohr magnetons, divided by 120 times 10 to minus 30, which is 1.545 10 to 5 ampere per meter. So this is the magnetization in SI units. So this is SI. And on the other hand, we have the following conversion between SI and CGS for magnetization. 1 EMU per centimeter cube magnetization is equal to 1000 ampere per meter. So the magnetization is also equal to 154.5 EMU per centimeter cube in CGS units. So we found the magnetization both in SI and CGS. Now there's a problem here at the end to think about. What does it mean to have a permeability of 0? Corresponding value of susceptibility would be what, and any materials that have these properties. Okay, so for this part, so let's remember what permeability is. Permeability is mu r times mu 0. So this is going to be 0. So this implies we have B is equal to mu times H is 0. So magnetic flux, therefore, magnetic flux cannot penetrate this material. So we find magnetic induction to be 0, therefore the flux inside will be 0. So if I use the SI constitutive relation between MH and B, if I take this equation and divide it by H, this will give me mu 0 M over H plus 1, and B divided by H is mu, so mu over mu 0 is susceptibility plus 1, so this is mu r, and this is equal to 0, so therefore the susceptibility is equal to minus 1. So we find that this implies a susceptibility of minus 1 in SI. And what material has this property? So you have a minus 1 susceptibility. That means we have a perfect diamagnet, and the perfect diamagnet is superconductor. Due to the Meissner effect, they have no flux, magnetic flux inside. The flux is expelled and the susceptibility is minus 1. Okay, so we considered a material that has one iron 3 plus ion and one chromium 3 plus ion inside, and the iron and chromium ions are have magnetic moments that are anti-parallel to each other, so that 5 minus 3, 2 Bohr magnetons per unit cell is the magnetic moment per unit cell. The volume of a unit cell is also given 120 angstroms cube. So we find the magnetization by dividing 2 Bohr magnetons, magnetic moment per unit cell, with its volume, and the answer is 1.545 10 to 5 ampere per meter in SI. And for CGS conversion, we just have to divide it by 1000 to obtain the answer in EMU per centimeter cube. And additionally, we thought about what it means to have a permeability of 0. A 0 permeability implies a minus 1 susceptibility, which is a perfect diamagnet. That would be a superconductor, which is due to the Meissner effect.